So far, everything we've drawn has been on screen. Well, of course it's been on screen. What's the point of drawing something off screen where we can't even see it? It turns out that being able to draw off screen can be very handy. Let's take a look at a couple of examples that use this technique. Here's a really simple sketch. There's a photograph in back, and in front, a graphics object I'm controlling with my mouse. Think to yourself for a second how you might create this graphics object with those 4 circular transparent holes. What combination of boxes and lines and curves could you use to make this, particularly with those holes? It would just be crazy. One thing you could do is to draw the shape with a graphics program like Photoshop and then save it as an image with transparency. But then the shape would be fixed. I'd like to be able to change the object as the program runs. Here, I'm pressing keys on the keyboard to make the circles bigger and smaller, and I can also make the whole thing bigger and smaller. You wouldn't be able to do this if the shape was saved in a file. Drawing this shape with the tools we have so far would be very hard and it would be very slow. But with off-screen graphics, it's easy and it's fast. Here's another example. I've taken a photograph and typed a letter over it. Then I used a technique we saw when we looked at images to fuzz the thing out. I'm just swapping pixels with their neighbors. The results look great, but the process is pretty slow. Using my keyboard, I can type another letter. For example, I'll hit the letter K right now. The picture stops, and now I'm recomputing the whole thing. Starting with the photo, I place the letter K on top, and then I fuzz everything out. It takes a few seconds, and now we're back. Again, think to yourself, how would you write this program? If you started fresh for every frame with a black background, and then you drew the rotated photograph and the letter, and then you ran the fuzzing routine, every frame would take 5 or 10 seconds to draw, and that would be terrible. But here, we only have to wait when we have a new letter, and then we see the resulting animation run smoothly. Of course, I'm doing this using off-screen buffers, and they make it an easy program to write. Here's the basic idea. Of course, we have a graphics window. It's the thing we've been using all along. We can also tell the computer to set up an off-screen graphics window. Sometimes this is also called a buffer, just as the on-screen window is sometimes called a frame buffer. The off-screen buffer starts out completely transparent. I'm indicating that here with the little white and gray checkerboard that we're used to from programs like Photoshop when they want to show us that something is transparent. This off-screen buffer is not visible. This lives in the computer's memory, but we can draw into it anything that we can draw on the screen. We can draw shapes, we can draw text, we can draw triangles and curves, we can draw images. Anything we can draw on screen, we can also draw into this off-screen buffer. Now take a look at the graphics window. Suppose I've drawn some stuff, and now I want to draw the contents of the off-screen buffer into the graphics window. This is really easy. Processing thinks of the off-screen buffer as an image, just like a photograph. So we can tell it to draw the image of the off-screen buffer right into the graphics window. And bam, there it appears on top of whatever else we might have drawn. And now we can continue drawing new stuff on top of that, just as though we had drawn a photograph. So let's look at the mechanics for this. An off-screen buffer is an object of a new type. The type is P graphics. The P stands for processing, of course, and both the P and the G are capitalized. So here I have declared a new object called Scratch of type P graphics. This is an object just like the other objects we've been seeing, so we're going to be sending it lots of messages. So you might expect that the very first thing we do is we call the constructor and we hand it whatever arguments it needs. And that is a perfectly reasonable thing to think, and unfortunately, that's not the way this one works. This is a weirdo exception. Instead of calling new P graphics, we call a custom routine to make a new pgraphics object, and that routine is called create graphics with a capital G in the middle. This is goofy. I wish we had a normal constructor for this thing, but we don't. And if we are going to have a thing like this, it should be called create pgraphics, because that's what we're making. But this is the name. So, okay, this is how we make a new graphics object. What are the arguments to create graphics? It takes 3 arguments. The first 2 are the width and the height of the graphics object we want to make. This is just like the width and the height that we give to size. The third argument is a keyword. This keyword identifies the renderer that processing should use. The renderer is the batch of software inside processing that actually does the drawing. Processing has several different renderers that are built into the program that it can use for you. The default renderer, which is the one that's been drawing everything for you so far, is called Java 2D. All capitals with a 2 in the middle. It's just one word. This is a keyword. And this is the default renderer. And frankly, for a long time, it's the only one you're going to need. And I would just say, stick with this. If you look up the documentation for Create Graphics, you'll find that there are other renderers. They go by various names, and from time to time, new ones are introduced. But again, we're just going to stick with Java 2D always. So, okay, we know that our new graphics object is of type pgraphics, and we make one by calling create graphics. Let's actually make one of these things and draw into it. So I'll create a new pgraphics object, and I'll call it boxpic, because it's going to be a picture of a box. The first thing we do is we create the pgraphics. So I call create graphics with the width and height that I want it to have, and Java 2D at the end. This will create the off-screen buffer in computer memory, and initially it's completely transparent. This can be smaller than your graphics window, or bigger, or exactly the same size. It can be any size you want it to be. Now I want to start drawing things into this off-screen buffer. But before we do, we have to tell processing, hey, set up this thing so it's ready for me to draw into. Unfortunately, Create Graphics doesn't do everything. It does part of the job, but it doesn't finish the job. To get the thing ready for drawing, we have to send it the message, begin draw, with a capital D in the middle. This takes no arguments, but it tells processing, finish the job of getting this thing ready for graphics commands. Of course, when we're all done drawing, we're going to call end draw, which also takes no arguments. Between these two calls, begin and end, we can send any graphics command to boxpic. So for example, let's start with background. I'll clear the background to white. So I send the message background to the object boxpic. We do that in the normal way, boxpic.background, and then a color. Here the color is 255, so we clear to an opaque white background. Now let's draw a red box. So I'll tell boxpic to fill with a red color, and then I'll send boxpic the message rect with 4 numbers, the normal 4 numbers that we use for a rectangle, and into the off-screen buffer, it will draw the rectangle. And we can go on giving boxpic any of the graphics commands we've seen. Draw rectangles and circles, text, images, curves, whatever you like. Just remember to always precede it with boxpic dot. When you're all done and you want to copy the graphics buffer onto the screen, remember I earlier said that processing thinks of this like an image. It just draws the picture. And in fact, we use the command image, just like we did for photographs. The first argument is the name of the off-screen buffer, and then come the X and Y for the upper left corner where we want the picture to go. Image is very smart in this way. Its first argument can be either a P image, which is a photograph like we saw before, or a pgraphics. That's it. That's everything you need to know to create an off-screen buffer, draw into it, and then copy the contents to the screen. In part 2, we'll put all of this into practice and make the 2 examples that I showed you earlier.